inviting me to give this talk, and I'm honoured to be up first today. I thought what I'd talk about is an application you may not have thought of for the tools that you use in science and data analysis, and that is in business case analysis. So that's, I guess, what I'll try and achieve today in this talk, basically twofold. One is to tell you what business case analysis means, and in particular Monte Carlo business case analysis. And secondly, try and give you the idea that using Pandas to do it is not completely crazy. So what is business case analysis? Well, basically I'm talking about any big investment decision that a company needs to make. They usually do some sort of analysis to decide whether it's going to be a profitable venture or not. And usually that takes the form of a spreadsheet, and it basically involves taking a lot of inputs such as costs and revenues and volumes, market share, all that sort of stuff, turn it into a measure of profit. And this is one representation, a suggestive one, of what that might look like. And the idea here is, obviously, the way I've drawn it is emphasising the fact that you only get a single figure out of it in the typical way that it's done. So you make a bunch of forecasts about your costs and your volumes and your revenues, and you get one single profit number. Of course, that doesn't tell you whether, what's the chance of losing money in this, or what's the chance of making $2 million. So for that, a lot of companies are turning to Monte Carlo business case analysis, where you would get a histogram or some sort of distribution. And of course, that's very natural for scientists to think in terms of distributions and error bars and so on. It has its challenges, of course, because you have to assess what the uncertainties are in the inputs. What's the possible range of volumes, and put some sort of actual probabilities on that. And that's quite an art to do that well, to counter the various cognitive and motivational biases that people have when doing that. So there are definitely challenges to doing it. But the advantage is you can now start to talk about what are the chances of losing money or other sorts of questions. And I've done this, I used to work at PricewaterhouseCoopers as a consultant where we used to do this sort of work, and we'd always use spreadsheets to do it. And spreadsheets have some fantastic advantages in that they're very easy to use, you can get going very quickly, they're very visual. So that's traditionally where it's done, and most chief financial officer areas will use spreadsheets a lot for that, and they're very comfortable with it. One of the outputs that you can get, and there are add-ins you can get to Excel that will do this for you, is this is called a tornado diagram, which is another output in addition to that histogram I just showed you of profit. This will actually show you which are the inputs that the uncertainty in really matters. So if you were to explain what that top bar means, for example, if you were to hold all the other inputs at their expected values and just vary the volume from its lowest value to its highest value, and to be precise, I mean, say, over an 80% confidence interval or some confidence interval that you define, what would be the change in the profit if you do that? So in this example, it's pointing out to you that volume and price, and to some degree the third one there, they're the ones that will really determine whether you're profitable or not. And things like your fixed costs and to some degree your variable costs, you don't need to spend quite as much time thinking about what those uncertainties are, because they won't have such a big impact on your profit. So getting back to my comment about spreadsheets, why would I even talk about doing it in something other than a spreadsheet? There are many problems with spreadsheets, which I'm sure you're familiar with, namely that, to just give you a few examples, when you basically got to put your formulas in every single cell, so you're repeating the same formula many times. When you want to add another row or column to a table, that you've often got to just double check that your summation formulas and so on are still picking up the right ranges. If you want to add another dimension, that's pretty tricky. If you want to add another whole sort of table, it can take a bit of surgery on your spreadsheet to fix that. They're quite hard to test. If you're not experienced, in developing them, the logical flow can get pretty tangled. So there's some things that you're probably already recognising. If you use a programming language, for example Python, you're going to get around a lot of those problems and make your work less error prone. So they might sound a little bit abstract, what I've just gone through, but just to point out that they do have real world consequences, I've just pulled out 2 headlines from the last couple of years which have at their root spreadsheet problems. And the first one is some analysis done by 2 economists, Reinhardt and Roghoff, who you may have heard of. They wrote a paper called Growth in a Time of Debt. They wrote a number of papers, but that one in particular, and in that one they found that when countries took on too much public debt, above, say, 90% of annual GDP, there was a bit of an inflection point and their growth rates slowed down. So this was an argument to not take on too much debt. And that's been adopted by a lot of countries or as a sort of intellectual underpinning for the policies of some countries towards austerity. Now it turns out that actually when they made their data public, there were some problems in their analysis which people have gone through. And one of them was an Excel spreadsheet error where they were summing over a table, a list of countries, and they just left off the bottom few countries because the range didn't go far enough down. And unfortunately, Australia was one of those countries. And in fact, a lot of other countries near the start of the alphabet. So when and it turned out when you fix that problem and 1 or 2 other problems as well, then this inflection point disappeared. So that's one big one, and then another was in the last few years, again, a trader at JP Morgan in credit default swaps took a very large position, which led to a very large loss and a fine as well by the US regulators. And it turned out that one of the reasons, there were again many contributing factors, but one reason was their spreadsheet, which calculated the risk of the position, had a formula wrong in it in which it was using a sum instead of an average, or maybe an average instead of a sum. And as a result, the risk was apparently half of what it would have been if they'd used the other formula. So he was able to take more risk than the company realised. So they're just 2 examples, and they lost billions of dollars in that position. So just to give you the sense that these are real issues, and there's in fact quite a fun website you can go to if you like that sort of thing, European Spreadsheet Risk Interest Group, where they actually have a page called Horror Stories where they go through lots of these things. Oh, that's come in straight away, has it? Okay. Okay, so that's why spreadsheet. You should just have a bit of pause for thought before you launch into doing one of these sorts of things in a spreadsheet. Now, you can use any programming language, I guess, instead of a spreadsheet. And a lot of people are using, or some people are using R to do this. There's a book that came out last year by Robert Brown called Business Case Analysis in R. And so certainly Pandas isn't the only option, but I like Pandas. In fact, some of this work that I developed for a client, I did in R first because they like R, but I'm trying to convince them to use the Pandas version or the Python version. So as it says up here, one reason why I like to use Pandas for it, as opposed to say just raw Python or some other programming language, is if you think about the way you structure your data, especially in a spreadsheet, you'd have tables. And in a spreadsheet you'll add, if you want to manipulate that data, you pretty much have to use the position of the data in the table as the index. In Pandas you can index by name. So if you've got a cost table and a price table, then it doesn't matter if your cost of apples is the first line and your price of apples is the second. If you reference off apples, then you're going to pick it up. So that just adds an extra level of robustness that you wouldn't have in a spreadsheet. Secondly, it can handle missing data. So suppose in one of your tables you had bananas and it wasn't in the other one. Well, a spreadsheet's going to have trouble with that, but in Pandas, you can determine what the behaviour is. And sometimes the behaviour will be that you should, that's fine, like say you don't grow any bananas, then it doesn't matter that you don't have a cost. And you can determine that behaviour, or in some cases the fact that you are missing a cost, say you were growing bananas and you don't have the cost, well, that's a problem. So you can set up that sort of behaviour in your analysis. And the third reason why I think it's a great tool is that you can broadcast dimensions. What I mean by that is, say you now realise that actually your cost depended on what farm you were growing these trees on. So you want to restructure your data like that and say, okay, in farm A the cost is 15 cents per kilogram of apples, but in farm B it's 12 cents. But the prices don't depend on the farm. Well, in Pandas, when you combine this data together, it will naturally just put the cost of the pears and broadcast it out so that at each farm it's the same. So that gives you a lot more flexibility than you'd get in a spreadsheet. That's the reason why I like Pandas. Now to just dive into, it could be, I guess if you're not familiar with Pandas, you might think, well, it could be a bit scary to do it though, because the spreadsheet's so simple, right? So this bit I'm trying to now give you the idea that it's not that hard. Reading the data is very simple. Oh, well, there's 4 steps, perhaps going back a step. There's 4 steps that you might think of in doing the analysis. One is reading in the data. The second is then simulating, by which I mean drawing some random distributions. So you've got the distribution of inputs. You want to simulate it, draw out some numbers, some random variables from there, and then actually do some calculations on it, calculate your profit, and then report it. You don't strictly have to simulate. I guess if you wanted to be pretty hardcore about it, you could actually work with the raw mathematical, formulation of the distributions, but that can get pretty complicated if you're doing complex calculations on it. But you could do that, say, in Mathematica or something if you wanted to go that route. So reading data is very simple. There's basically this read CSV. You just read it from a comma-separated values file, or you can even read it from Excel. So that's pretty straightforward. That'll give you a table called a data table, a data frame rather, called costs. And I'm going to do a quick demonstration in an IPython notebook after this slide, just to give you some idea of how it works in practice. Get your hands dirty a bit. Simulating is a little bit trickier, and that I'll go through in more detail in this demonstration, but I'm just trying to give you the idea. It's only a couple of lines to do that too. Calculation's particularly easy. You just say you've got a data frame with a volume and a price in it, and you want to calculate the revenue by multiplying them. It's literally as easy as that. And then finally, reporting is easy as well. If you want to create a histogram, there's the hist function. If you want to dump all your results back to Excel, that's easy too. Okay, so over to a quick demonstration. When I finish this, I'll come back and just have a couple of slides left to just go through the good things, the bad things, and the next steps about using Pandas. Okay. Is that good enough? So a quick demo of some of the commands that you'd use to do this. First of all, you just need to set it up, which you may have seen before. It's based on NumPy or NumPy, as Ed was saying. And the model I'll just demonstrate here is a pretty easy one. It's just what I described before. You've got some costs, you've got some revenues. Those revenues are price times volume, and the volumes, just to add an extra level to it, are calculated as the number of trees on the farm times the average amount of fruit that you get off the tree. And so it's that amount of fruit that you get off the tree that we'll simulate in this. So to read in the data, exactly like I described earlier, I've just added one extra argument there so that any extra spaces in the file don't get put into the data. And you've probably seen this sort of thing in Pandas. It comes up quite nicely in the IPython notebook as a data table there. So the CSV file is literally that same structure. Then we could read in the amount of fruit per tree, and here I've just specified the mean and the standard deviation of each. And as you can see, I've a few little things I've put in here. In the top one, the number of trees is per farm, and in the bottom one, the amount of fruit that the trees grow is not dependent on the farm, so we're going to see broadcasting happening. I've also got red delicious in the second one, but not in the first one, so you'll see how the missing data works as well. And here it is, I guess all of that is about to happen in this merge command. So I've got the pandas.merge up there. That's just put those two tables together, and you can see it's broadcast out in the first two lines. Farm A and Farm B, both the Granny Smith apples have both got means and standard deviations of 230. And red delicious is missing because if you just do merge without any describing how you do it, it only keeps the keys from the first table. So the fact there were no red delicious in the num trees table means you don't get any in the output. But if you want them, you can just supply a parameter like this, the outer here, and it will then keep both of them. And you'll see there's not a number down the bottom there, which you could then deal with how you want to. And I'll give you an example of that in a bit. So that's actually two of the steps, I guess, reading and then merging the data into one table. I'll just run quickly through the way that you then do the simulation, or the way I've done it. You may have a better way, in which case I'd be interested to hear. So we've got this table fruit, and we want to replace those last two columns with an actual sampling, and then actually have more rows, one per iteration, okay? And the way we're going to do that, I'll just take a bit of a detour and talk about group by, because we're going to do it using this group by command. Group by will let you aggregate some of this data and then do some statistics on it. So for example, if you wanted to count how many different rows there were for each farm, you could use this command, group by farm, and then count. And you can see it tells you there are 3 rows for farm A and 2 rows for farm B for each column. You don't have to group by just one thing, you can group by 2. So here we're now seeing there were 2 varieties of apple at farm A and 1 variety of pear, and 2 varieties of apple at farm B. And you don't have to just do simple things like count. You can actually define your own functions as well. So for example, if you use this apply, it will apply this test function to each row and write it out. And my test function is indeed just to count, so we get the same result. But now we've got the tools we need to do this simulation. If instead of just counting, suppose I actually put out a random unit normal here, then you'll see we now get, and I'm counting as well just to keep the continuity with the previous line. So you can see we now have a count and a random variable coming in at each position. That gives you a couple of rows. We actually wanted a couple of columns. We actually wanted a couple of rows for each one. So now if we use a function like this where we're returning a data frame with 3 random normals in it, it'll produce this output. And you can see now we're getting pretty close to what we want, where we have where we've drawn 3 random variables from this distribution for each row. The last step we need is simply to use the mean and the standard deviation we actually had in the original data, which we can do with this test function comes in with a group, and you can actually just pull the mean and the standard deviation from that, and so we're away basically with that. And there's our data table with the simulations in it. You'll find in Pandas there's often a lot of data manipulation you need to do just to get the exact form that you want. So for example, this doesn't have a column name for the iteration. So if you want to add that in, one way you can do it is just this rename command here. I've also done reset index, so you can go back and forth between having your indices grouped in the nice way you see in the previous cell to having them just listed out every time. And pretty much different tasks, it's better to have them in different formats, I've found. But you can see now we've got an iteration column. And just to give you that was only with 3 iterations. Just say you wanted to use 1,000. It's just as easy now because it's all just a parameter. And then in this example, rather than list out all 1,000 iterations for each farm, I'm just giving you a describe. You can see I've run describe up there. And it's just giving you the mean and standard deviation and some other parameters about that simulation. And you can see the means and standard deviations add up about to where you want. Okay, so that's sort of the simulation part of it. The calculation part then is as easy as I said, with any luck. So what have we got? We've now got this sim fruit per tree table where we've simulated, and the head part of that command just shows you the first few lines. We now put the number of trees back into that table, which came out of there somewhere along the way. And now we do this calculation where we simply add in a volume row, add in a volume column, sorry. And you can see there, so that volume column at the end here is just the product of the number of trees and the fruit per tree. So from there, I'll just skip over a few lines because basically I'm just reading in some costs and prices and so on, and we're going to merge them all in, and then we get to a line like that where you've actually got a revenue coming in for each of these, and then a real world thing here now comes in, which is that's all very nice, but actually some of your costs might not be down at that very granular level of varieties, every variety of fruit. So for example, fixed costs might just be to run farm A, you've got some fixed cost. And so there's an example of a fixed cost there. And the way that you would deal with that is you've just got to use this group by function again to get all your data, your simulations back up to that level. So if we group by farm and iteration, we'll now have a data table we can apply the fixed costs to. And we can do that again with merge. And the screen's not quite wide enough, but you can see we've now got this fixed cost guy over here, and it just applies to farms. It doesn't apply down at the level of the variety of fruit. And because it didn't have a fixed cost for farm B, we've got nans coming in here. And just to show you how you can deal with that, quite simply, you just use this fill NA command, and that would replace it with 0. And you can have much more sophisticated fill NAs than that, where you fill forward or use a function. So then we're in a position we can now calculate the profit and even sum it over the farms, and here's what you might finish with at the top here, where for each iteration you've calculated the profit. So I've gone through that in quite a bit of detail, but I guess the idea is just to show it's not too scary. The logic is, you can contain all your formulas in just one place. You don't have to push them across many cells in a spreadsheet. So I like that. And just to put it all in one place, it's just a bit more than a screenful, I guess, of code there to actually do that. Let me run it. So I've done it for 10,000 iterations here, and then you can see you can print out some histograms. You probably need to spend a little bit of work on prettying them up, but the basic output is there. And you can also calculate things like what's the chance of a loss based on that. One cool thing about Pandas that I haven't mentioned that I'll just take the opportunity because there's a little bit of time is this Boolean indexing feature here. So here it's only going to be summing up. This sum will only apply to rows where the profit is less than or equal to 0. So that then sums up how many times profit was less than 0, and by dividing by n you're then getting a fraction of the times. So you get, say, a 7 or 8% chance of loss there. In all of that, these are the key Pandas functions that I've used in all of that, if you're interested, just as a summary. Pretty much, reading in the file with read CSV, then merging, group by and apply, and fill NA and hist, and then these features of broadcasting and Boolean indexing. And then a little bit of data manipulation, or the structure manipulation, things like dropping, resetting the index and renaming. All right, so then just to finish up, the good things again are that it's easy to add new farms and crops when you do it this way. You just put them into your data files and it sort of all works. If you wanted to add whole new dimensions, so in practice you'd want to have profit per year, that's pretty easy to do because it's just another dimension. It's also easy to add tests. I haven't gone through that in this example, but I've got a repository on Bitbucket where I've got this example and some more examples, and then actually have some tests there, so you can see that that's quite doable. And as a result of all those things, it's less error prone than using a spreadsheet. The bad things about doing it this way, I guess, as you might expect, spreadsheets are really easy. I don't see using Pandas as, it's not going to take over anytime soon using spreadsheets to do this, but I think in some key situations where there's a lot of money at stake, I think it's not a bad approach, and even if companies themselves don't sort of take this on, I think there's probably a role for consultants, specialist consultants, to have these skills and do that sort of analysis. Pandas itself is a great tool, and it's fantastic that it's available. It does have a few things that I found a bit non-intuitive, like using sometimes it's a bit inconsistent to my mind of whether you put the row or the column name first instead of the arguments. And in fact, the fact that it uses this hierarchical indexing so that everything's a two-dimensional structure isn't my natural way of thinking. I tend to think more, I guess, like the underlying NumPy has the multi-dimensional arrays. So sometimes just getting the right commands to do what you want can take a bit of work. But when you get there, it looks fairly obvious, I guess. And then finally, next steps, I mentioned the Bitbucket repository where I've put a few routines to help make this a little bit easier in practice and based on some of the things that I've found when trying to do this. For example, when you're drawing from, you're not always going to want to use normal distributions. In fact, I wouldn't recommend it even for the example I gave here of the fruit on the trees, because you're going to have disasters and other sorts of things. You don't want your numbers going below 0. So I've got a routine in there which, based on the parameters that you specify in your input file, it'll work out what sort of distribution you wanted. Another important one is you don't want to rush into Monte Carlo analysis before you've done the base case situation. As much as I maligned just doing a single case, it's still a good place to start, because if you rush too quickly into complicating it, you kind of often find it quite hard to work out if there are problems as well. So there's some code there so that if you pass in n equals 0 instead of n equals 10,000, it will return, using the same logic and all the same calculations that you've done, it will return the base case rather than a simulation, so that you can see whether your base case makes sense. And similarly, sensitivity analysis, that tornado diagram I showed at the start, where you just vary one thing at a time, there's some code to do that as well. Some specialised input-output stuff to make things like years easier to input, and this talk itself is there too. So I guess the key message I'd like to get across really is that this might be an interesting use for Python and Pandas that you haven't thought of before, and hopefully it would improve investment making in businesses, and beware of spreadsheets. Thanks very much.
Thank you very much. So we don't have any time for questions, but please speak to Arthur afterwards. So thank you very much, Arthur. So Arthur runs a consultancy business developing web apps with a math and analysis flavor. And he also runs